Welcome friends to yet another video on solve problems with explanation on electromagnetic fields from university exams. Uh, in this video we are going to see example 5 based on vector analysis. This example is based on determining a field, that is a vector field, and its orientation at a given point. Please remember that this is based on computation of vector field and not the field intensity. So you don't get confused with computation of electric field intensity and this particular field computation. So let us move ahead and see the question. Here a vector field vector S is expressed in the Cartesian coordinates form. So it is 125 upon x minus 1 square plus y minus 2 square plus z plus 1 square multiplied by whole bracket x minus 1 ax cap plus y minus 2 ay cap plus z plus 1 az cap. So in this particular one we have to first evaluate vector S at a point 2, 4, 3, that is point P. Then we have to determine a unit vector which gives the direction of this vector field at point P. And thirdly, we have to specify or find out a surface fx yz as a function of x y z for which the magnitude of this vector field equals to unity, or a value becomes equal to 1. So this is a slightly different kind of question as compared to the earlier 4 videos. Here we are dealing with a vector which is given in the generalized form. It is given in the form of a field which depends on variables x, y and z. So let us solve this particular example, see the solution for this. So first of all we have to evaluate this vector field vector S at given point P having coordinates 2, 4 and 3. So let us see. For finding out this vector S at a given point, we have to substitute coordinates of point P, x equal to 2, y is equal to 4 and z equal to 3 in the equation given for the general form of vector S. So we substitute x, y and z coordinates instead of x, y, z in the given equation. So it becomes 125 upon 1 square plus 2 square plus 4 square multiplied by in bracket vector ax cap plus 2ay cap plus 4 az cap. So simply this calculation turns out to be vector S at point P is 5.9523 ax cap plus 11.9047 ay cap plus 23.8095 az cap. So this particular computation in part A is simply substitution of coordinates of point P in the standard equation given for vector S. So let us review. Vector S is given in the Cartesian form. It is a vector field rather than a vector at a particular point. It is a function of x, y, z in Cartesian form. So for this vector field we have to first obtain its value at one of the points, that is point P. Then we have to determine the unit vector that gives direction of vector S at this point P again. And lastly we have to determine the equation of a surface on which the magnitude of this vector field vector S becomes equal to unity. So we solve the first part of this particular problem of evaluating vector s at point P by substituting the coordinates of point P, x equal to 2, y equal to 4 and z equal to 3, and hence we get vector s as equal to 5.9523 ax cap plus 11.9047 ay cap plus 23.8095 az cap. Now let us move ahead and determine the second part of this particular problem, that is a unit vector at point P for vector s. So already we have determined the vector at point P as vector s. So all we have to do is simply express that vector and divide it by its magnitude. So vector s at point P has been determined to be 5.9523 ax cap plus 11.9047 ay cap plus 23.8095 az cap in the numerator, and in the denominator it is simply square root of sum of the squares of these three components along x, y and z directions. So we substitute these values and evaluate this unit vector as cap as 0.2182 ax cap plus 0.4364 ay cap plus 0.8728 az cap. So computation of this particular unit vector is done in a manner very similar to uh, that we have studied or learned in the earlier four videos examples, wherein we were calculating vectors and unit vectors on a regular basis. Now let us move ahead further and solve for the third part of the question. Is slightly it is difficult as compared to the first two. So in this case we substitute the condition that magnitude of vector s equal to 1. So on the left hand side you can see we are substituting the general equation, not the value of vector s obtained at point P. Left hand side, magnitude of vector s. It is not mentioned that we have to evaluate it at point P. So we substitute the very first general equation, substitute the vector and try to obtain its magnitude. So the left hand side, the magnitude can be obtained as square root of sum of the squares of x component, y component and z component of the vector. So this particular part is getting simplified as 125 upon x minus 1 square plus y minus 2 square plus z plus 1 square in the denominator, multiplied by square root of x minus 1 square plus y minus 2 square plus z plus 1 square and equal to 1. So let us review what we have done in this particular slide. First we have determined unit vector, vector as cap at point P as vector s upon its magnitude. So vector s is the same as we have evaluated in part A. We substitute this vector and its magnitude in the denominator and obtain the value of unit vector as 0.2182 ax cap plus 0.4364 ay cap plus 0.8728 az cap. Later we move on to substitute the condition mod of vector s equal to 1. Remember, this is not at point P, this is a general equation, and we simplify the left hand side of the equation by substituting the magnitude So here it is, the form, and we have to solve this equation such a way that we obtain a function in terms of x, y, z. So let us see. This equation gets further simplified as square root of x minus 1 square plus y minus 2 square plus z plus 1 square is equal to 125. Squaring both sides and rearranging the equation, we get x minus 1 square plus y minus 2 square plus z plus 1 square is equal to 125 square. If you closely observe this equation, then we can clearly see that this surface or this function is a sphere having radius as 125 meters and with its center located at point 1, 2, minus 1. So let us take a review. We have simplified the equation from mod of s equal to 1. So this is the form obtained. If we take the square of this equation on either side and get x minus 1 square plus y minus 2 square plus z plus 1 square equal to 125 square. So this is a standard equation for a sphere in 3 dimensions having radius equal to 125 and center located at 1, 2 and minus 1. So this way, uh, in this particular example, we have worked with a vector field in the Cartesian form and general equation in terms of x, y, z, and we have determined the vector and also a surface over which the vector will have value equal to 1. Thanks for watching. Please like and subscribe this channel if you find it useful, and keep watching. Thank you. Thanks.